Alright, good morning everybody. This is the first of two videos for section 3.2 on solving rational equations. So on the last video we went through talking about solving rational expressions. Simplifying rational expressions. So we talked about factoring, we talked about canceling things out, top and bottom, and then we talked about multiplying and dividing. This is going to mostly focus on adding and subtracting when we're dealing with these, but the big thing is toward the second half of this, we're going to push toward finding common denominators. And to do that, we are still going to have to factor. So factoring is going to pop back up after these two videos. So it's 3.2 part 1 and 3.2 part 2. We're done with factoring. So we're completely shifting gears when we talk about transformations. But for now, you may want to have your factoring, your boot camp notes out with you if you need a little help. All right, so first thing we're going to talk about is cross products property. You've seen that before. It's just cross multiplying. All right, and it is one of those things that people tend to try to do instinctively, and it's not always the appropriate situation. So one of the things we're going to talk about is when do you want to do that. So in this case, when it's a proportion, cross products are equal. And when we're talking about a proportion, cross products are equal. So for something to be a proportion, it's exactly what you remember, hopefully, back from late elementary school. It has to be two fractions with an equal sign in between. And that sounds dumb to go back over, but a lot of times I'll have students that try to cross multiply without actually, in an inappropriate situation, where it might be two fractions being added together and they're like, oh, I'm just going to cross multiply. All right, so it only works if it's one fraction on either side of the equal sign. Then you can cross multiply and solve. Just as a quick refresher from back in the day, so if I was going to cross multiply, these are two proportions right here. I'm sorry, that's one proportion with two fractions, equal sign in between, so then I can cross multiply. So you're multiplying on the diagonal. So those two get multiplied together. Oh, that is quite thick, so that doesn't help. And then those two get multiplied together. All right, so that's what we're looking for. So we would have 1 times 10 equals 2 times 5. And you end up getting 10 equals 10. So you can use that property to help you solve some of these equations. And we will be looking at canceling and solving. Some of these will be quadratic equations that we end up solving. Some of them will be linear equations that we end up solving. All right, so for number 1, we have exactly what we talked about. We have two fractions, equal sign in between. So we can go through and multiply. So we would do 3 times 4x plus 5. And then we're going to do 3x plus 1 times 9. All right, so that's going to look like this. Sorry, the font sizes are a little wonky on my pen today. So we have 3 times 4x plus 5 equals 9 times x plus 1. And then we're just going to distribute both of these, and then we'll see what we've got and solve it. So that would be 12x plus 15 equals 9x plus 9. All right, I'm going to subtract 9x from both sides. So we have 3x plus 15 equals 9. I'm going to subtract 15 from both sides, and that's going to give me 3x equals negative 6. And then I can divide both sides by 3, and x is going to equal negative 2. All right, so I'm not going to make you show your work for checking, but it is important that you check, but it's a little weird. You don't have to plug all the way in. What you really need to worry about are the denominators, because one of the issues, the things we learned about fractions way back when, is you can't ever have 0 in the bottom of a fraction. So whenever you're solving these and you have like x plus 1 in the denominator, you want to make sure that whatever you find for x won't give you 0 in the bottom. So you just have to check. You don't have to show your work. You just have to look at it and go, okay, is this going to give me 0 or am I good? So if I put in -2 and I look at the denominator of the first fraction, -2 plus 1 is going to give me -1. I'm fine. The second one, it's 4x plus 5. So 4 times -2 would give me -8. -8 plus 5 is -3. I'm fine. All you want to do is check and make sure that you don't have a 0 in the denominator. If you don't, there you go. You're good to go. All right, so let's take a look at the next one. Same setup. It's two fractions with an equal sign in between. So we can multiply 2 times 7, and then we can multiply x plus 5 times x. There we go. So that's going to be 2 times 7 equals x times x plus 5. So that's 14 equals x squared plus 5x. All right, so this is a quadratic. All right, we've got an x squared in there. So we know a bunch of different ways to solve quadratics. We have we don't have completing the square, sorry. We have quadratic formula, we have factoring, we have graphing. All of those work. But all of those need to be equal to 0. So before we can deal with it, we got to move this over. And there we go. All right, so from here, you have a choice. I don't care how you solve that. A good chunk of pre-cal, however, is going to be calculator inactive. So I would suggest, if you're not comfortable with either the quadratic formula or factoring, that you practice with that more. Because if graphing is the only way you did it, you're going to run into a little bit of trouble. So make sure that you are brushing up on that. Hopefully working through these lessons are helping you, refreshing your mind on factoring. But I would make sure that you at least have one of those in your belt that you can do. So you can factor. You can do the quadratic formula, or you can graph. All of those will work. I'm going to do the factoring method just to give you guys that extra refresher. Quadratic formula would totally work here as well. All right, so if I'm going to factor that, I'm looking for something that multiplies to be -14 and adds up to be positive 5x. Only numbers that multiply to be 14 are 1 and 14 and 2 and 7. So to get so it needs to be -14. So one has to be positive, one has to be negative. 1 and 14, whatever combination you do, there's no way you're getting 5. 2 and 7, it's doable. So we would need that to be a positive 7 and a -2. So positive 7 times -2 gives us -14. Positive 7 plus -2 gives us 5. All right, so we're here. And now we can split these up into baby equations and solve both. So I'm going to subtract 7 here. And I get x equals -7. I'm going to add 2. I'm going to get x equals 2. All right, before I'm done, I do have to go back and check my denominators. The second fraction is fine. The second fraction, the denominator is 7, so I wouldn't be plugging an x in there, so I'm good. For the first one, I gotta look. So if I plug in -7, -7 plus 5 gives me -2. That's fine, it's not 0. And then for the second one, if I plug in 2, 2 plus 5 gives me positive 7. Again, fine. Doesn't give me 0, so I'm good. So both of these answers will work. We're going to run into problems across this 2 lessons where we're going to have we will have both the start that sentence again. All right, we'll have problems where none of the answers will work. We'll have problems where one of the answers will work, and we'll have problems where both answers work. Okay, so we've dealt with the equations that are proportions. Now, if you look at the next part, they're not. All right, so in this one, we're going to have to go back to using least common denominators, which has been a minute. As you did those back in elementary and middle school, but it's been a while. All right, so least common denominator, what we're looking for is, we're going to start real simple, and then we'll, over the course of these two videos, get more complicated with our denominators. But what you're looking for is you want to have each piece of the denominator present, if that makes sense. So if you look at number 1, so the least common denominator, basically pull out each of those pieces. So x, we would need 3, and then 2 would be over 1. So if you multiply those together, you're going to get 3x. That's our lowest common denominator. So now what we need to do is multiply every piece of that equation by 3x. What that's going to end up doing is canceling out all of the denominators. I use parentheses to keep myself straight when I'm doing this, so I know what each term is. That's kind of optional. It's not a required thing. But like I said, for me, it helps keep me organized. Like the first parenthesis is my first term. Second parenthesis is my second term, and so on. But you do you. You don't have to cancel at this point. You will cancel on the next step if you don't cancel here. And honestly, canceling here saves you some time. So I tend to. So I'm looking at this one, going across, my x's will cancel. For the next term, my 3's are going to cancel. For the last one, nothing will cancel. So 2 times 3 is going to give me 6. 4 times x is just going to give me 4x. And then 2 times 3x is going to give me 6x. And from here, I'm just going to solve this equation. So I'm going to subtract 4x. That gives me 2. I divide both sides by 2. And x is going to equal 3. Double check your denominators. If I plug 3 in for x, I'm good. It's not going to give me 0. And that's it. So it's just a matter of following those steps every time. All right, so let's look at number 2. So it's going to be 2 times x times 1. So my lowest common denominator is going to be 2x. And again, go through and multiply your fractions. So 7 halves times 2x plus 3 over x times 2x, and 3 over 1 times 2x. Alright, then check, see what you can cancel. So in this one I can cancel my 2's. In this one I can cancel my x's. Can't cancel anything in the last one. Alright, so that's going to give me 7x plus 6 equals 6x. Alright, so I'm going to subtract 7x from both sides. So I'm going to have 6 equals negative 1x. And then I'm going to divide both sides by negative 1. Double check to make sure that works in the denominator. It does. So you're good. Alright, so these next ones, if you look, they're going to level up in difficulty just a little bit. Alright, so instead of just being a single number or a single letter in the denominator, we've got some binomials. It's still going to be the exact same steps, just a little bigger. Alright, so for this one, our LCD is going to be x plus 4 and 3. Alright, this x plus 4 is already over there, so you don't need to write it twice. If you do, it's not wrong, it's just going to be a longer problem for you to solve. But if there's a duplicate, you don't need to write it twice. There is an exception to that, but we'll get to that in the next video. Alright, so that's my LCD. I would leave it factored. I would not distribute that 3. Because if you don't distribute it, then you can cancel things in the next step. If you do distribute it, you're just going to have to factor everything at the end, and I would say let's save a little effort there. Okay, so that's going to be x over x plus 4 times 3 times x plus 4. And then we've got 1/3 times 3 times x plus 4 equals negative 12 over x plus 4 times 3 times x plus 4. Alright, so looking to see what we can cancel. The x plus 4's cancel, 3's cancel. The x plus 4's cancel. So I'm left with 3x plus x plus 4 equals negative 36. Alright, so combining those, that's going to give me 4x plus 4 equals negative 36. I'm going to subtract 4 from both sides. So 4x is going to give me negative 40. I'm going to divide both sides by 4, and I'm going to get x equals negative 10. Alright, I want to double check my denominators. So if I plug in negative 10 for x, I would get negative 10 plus 4, which is negative 6, which is fine. It's not 0, so we're good to go. Alright, so let's take a look at number 4. I wrote a little big there, sorry. For this one, our LCD is going to be x minus 2, 5, and then we'd have x minus 2 repeated again, so we don't need that. So we just have 5 times x minus 2. So x over x minus 2 times 5 times x minus 2, and then 1/5 times 5 times x minus 2 equals 2 over x minus 2 times 5 times x minus 2. So these get a little crazy looking at this step, but then as soon as you start canceling stuff out, it gets a lot easier. Alright, so over in the first one, the x minus 2's are going to cancel. In the second one, the 5's are going to cancel. And the third one, the x minus 2's are going to cancel again. So that's going to give us 5x plus x minus 2 equals 10. So condensing that down, that's going to be 4x minus 2 equals 10. I'm going to add 2 to both sides. 4x equals 12. Divide by 4. X equals 3. Oh, backing up. I messed up right there. 5x plus x is 6x, not 4. Sorry about that, y'all. Alright, so let's check that. Alright, so we got 6x equals 12. There we go. So I'm going to divide both sides by 6. I'm going to get x equals 2. Alright, so remember, got to check the denominator. So if I plug that in for x, 2 minus 2 is 0. So I can't use that answer. I don't have any other answers. So this problem is undefined and it has no solution. So this is where checking becomes important. Like I said, you don't need to write your steps out for checking, but you do need to go through and at least mentally check it. Because if you put x equals 2 as your answer, you would be wrong. So you got to be careful with that. And you can write words or you can write the symbol for no solution. It doesn't matter. Alright, last one for today. Alright, so for our LCD, we've got x plus 1 times 2x, and then we also have a 2x in the next one, so we don't need to add it in. So we're going to end up with 2x times x plus 1 as our least common denominator. So we're going to go through and multiply everything by that. And then we're going to go through and cancel. So the x plus 1's will cancel, the 2x's will cancel, and the 2x's will cancel. Alright, so over here, that's going to be 3x times 2x, so that's going to give us 6x squared. Over here, we've got negative 5 times x plus 1, so that's going to be negative 5x minus 5. And then over here we've got 3 times x plus 1, so that's going to be 3x plus 3. If you need to write those middle steps out, you totally can. So if you need to write it like this, just because there's a lot of chaos there, and then go to that next step, that is totally fine. If it helps keep you a little more organized, go for it. Alright, so that's a quadratic. We've got an x squared. So to solve our quadratic, we need to get everything over on the same side. It needs to be equal to 0. Alright, so I'm going to subtract 3x from both sides. I'm going to subtract 3 from both sides. So that's going to give me 6x squared minus 8x minus 8 equals 0. Alright, so I'm going to go through the process of solving this by factoring. You could do the quadratic formula, you could graph. First thing I'm going to do is I notice all of these numbers are even, so I'm going to factor out a GCF of 2. You don't have to, but it's going to save you some steps here in a second. Alright, so that's what I've got, that trinomial right there. That's what I need to factor. So I'm going to do box and X puzzle. So the first term goes in the top left. The last term goes in the bottom right. For the top of the x, that should be negative 12x squared. The bottom should be negative 4x. And I got to figure out what multiplies to give me negative 12 and adds up to give me negative 4. So it's going to end up being negative 6 and positive 2. And then we need to fill those in over here. Alright, order doesn't matter, where you plug those in is fine. Either way, you'll end up with the correct answer once you're done factoring. Alright, so we end up with those two terms. So we're going to have, or those two factors, I'm sorry. X minus 2 times 3x plus 2 equals 0. Alright, from here we want to make our baby equations. So 2 equals 0, x minus 2 equals 0, 3x plus 2 equals 0. Alright, can't do anything with that. For this one we're going to add 2 to both sides. So x equals 2. We're going to subtract 2 from both sides. So that's going to be x equals negative 2/3. You want to stop and check your denominators. Both of those work. So that's your final answer, both of them. Alright, that's it for video 1.